I'm delighted this morning to have the honor of introducing Dan Olsen, who's the winner of this year's Lifetime Research Award. So this is the most prestigious award that ACM SIGCHI gives out for research. We give one every year, and this year's award, Dan Olsen is a professor of computer science at Brigham Young University and was the first director of CMU's Human-Computer Interaction Institute. He's one of the earliest and most influential researchers in the user interface software area. His first contributions were in using formal language techniques such as finite state machines and the Backus-Naur Form to specify the syntactic structure of a user interface. He's published 3 books on user interface software, and many of his early systems were very influential and invented many of the techniques that we now all use in user interface software. We particularly pointed out the MIC system, which was an early and influential system for automatically generating user interfaces from semantic specifications. Dan's made important research contributions throughout the years, has a wide number of systems in many different areas, including CSCW, machine learning, and developing metrics and principles even for human-robot interaction recently. Dan's done incredible service to the ACM and in particular to SIGCHI, and he received SIGCHI's Lifetime Service Award for his many years of service a few years ago. He was the founding editor of the Transactions on Computer-Human Interaction. He played a key role in establishing the UIST conference and making it one of the most successful of SIGCHI's conferences. And he still continues to be extremely active. He's currently the Vice President for Publications for the ACM SIGCHI organization, and even this year at CHI, he's the Papers Chair. The title of his talk today is Creating the Digital Future, the Role of Interactive Systems. Please join me in welcoming and congratulating Dan Olsen. And he also gets this check. Ooh.
So when they ask you to give a talk like this, I'm never really sure what to say, whether to report the things that we've done, to imagine a future, to write my own epitaph. I'm not old enough for the last one, so I'm not going to do that. But what I thought I would do today is talk about why people like me do what we do within this organization. Because we spend a lot of time in this organization about users and users' needs and how they live and how they work and all of those very good things. But I have lived all my life in the world of software. It's what I love. I think I told my wife that when I die in the casket, I want a voice-actuated device that says, "Hi, how do I look?" She thinks that's terribly tacky. I think it would be the perfect end to the career. Geeky software is just what I do. But the question then comes is, what has that got to do in a highly people-oriented organization like CHI? And that's the question I want to talk to you about today. And it's a way that I found to think about that is I'd like to think about a medium. This is not the kind that looks in a crystal ball and tries to predict something in behalf of extracting money from you. A medium is a technology for expression. This happens to be a delightful Renoir, which I couldn't possibly reproduce myself. We all enjoy it. We go to museums. We look at things like this. But what we rarely do is look at the paint. That's what I'd like to talk about today. Not the painting, because I'm actually not a very good painter. I enjoy it. It's relaxing, but I'm not very good at it. What I'd like to do is talk about the paint, because that's what I think people who do interactive software do. We create paint. We create a medium for people to express themselves. Now, this paint actually comes in combination with brushes. The whole notion of oil paint and the technology for oil painting actually solidified itself about the 15th century. So this is a medium that has been enormously successful at producing a large amount of expression culturally. And it comes with a combination of a cyan, magenta, yellow color scheme, subtractive colors, pigments mixed with oil, and it comes with brushes. Now, yes, I know people paint with things other than brushes, but it's amazing what a small minority of painters that is. This basic idea that you take some kind of hair, you wrap it in a piece of metal, and give it a wooden or plastic handle. Millions and millions and millions of them have been built and created and used and put together with oily stuff with color in it to make pictures. It's a medium that just plain works. Now, this is Leonardo da Vinci, one of the great inventors of the Renaissance. And this is a painting that almost, well, actually nobody has actually seen the original. Nobody currently alive. This is the Battle of Anagiri. And this painting was never completed. The reason it was never completed was because da Vinci was dissatisfied with fresco. This whole idea of taking wet plaster, putting it on the wall, and trying to get paint to stick in it, he had an unhappy experience, he didn't like it, and he said, I am da Vinci, I will invent new paint. And so he did. He invented a wax-based process and the beginning of an oil-based process, and the problem he had is it wouldn't dry. And to get it to dry faster, he put coal lanterns in front of it, which made the wax melt and the whole thing ran, and he just gave up in frustration and went and got a different job. Because he was da Vinci, people copied, and what you see here is actually the copy of this painting. But the thing I wanted to point out was, at this early time, the role da Vinci had in not only creating paintings, but in the technology of how to paint. How do we do this? Now, the other thing I want to point out is he failed. It was a bad idea. The oil paint wasn't. That went on and became the most successful art medium. The wax was. But if he'd have never tried, we'd have never made the progress that we've made. This is the kind of role that I think people who do interactive systems plan on doing. How do we create new paint? Okay, so I'd like to talk about 3 properties of what I think creates a great medium. Then what I'm going to do is I'm going to go take this and look at interactive technologies in the light of these 3 properties. So the first one is the range. What is the set of possible things that you can express with this medium? Your medium creates limits on what you can express. It creates bias in the kind of paintings or the other kinds of things you will actually produce. So the range of possibilities has a lot to do with the quality of your medium. The thing we like about oil paint is the fact that we can generate all the visible colors, and by generating all the visible colors, we can, in principle, produce any image that the eye can see. That's a great range. That's not the same as the range that is easy to do with actual oil brushes and canvas. That range is actually much more limited. Creating a photorealistic representation is very, very hard with this medium. If you want to do that, use Photoshop. It's better. Okay, here's another medium, a related medium that many of you are familiar with. This is watercolor. Now, watercolor, as a range, in theory, can produce all those same colors. In practice, that's really hard. In practice, that's really hard. With watercolor, what you mostly get is a tint over the properties of the paper that you're using. So the paper comes through much more richly than it does in an oil painting medium, which can completely obscure whatever you're painting on. So the range actually changes. Now, there's another thing that watercolor does, and that is my principle number 2. Property number 2, that's the empowerment. When you create a medium, you're going to lower the barriers on the skills required to express yourself in this medium. So, before oil paint, it was tempera, which means you had to crack your own eggs and mix your pigment with those eggs in the right amount and hope that it stuck. Got oil paints, they were so excited because it was so much easier to work with than breaking your own eggs in order to make a painting. So the skills required were reduced. The other thing that happens in a really good medium is the cost, both in effort and money, of doing this. Now, let's go back and revisit these two again. If you've ever gone to the art store, which I do just for fun when I'm tired of browsing Best Buy, what you'll find is that the cost of oil paints and the cost of doing oil paints is about 10 times the cost of doing watercolor. A nice set of tube watercolors, $10. A good set of oils with the brushes to go with them, probably closer to 60 or 70. And you couple that with the canvases and it's a lot more expensive. So, in terms of cost, watercolor empowers a lot of people. That's why grade school starts with watercolor. In terms of the skills required to produce a painting, it's completely reversed. If you've done much watercolor, it's very unforgiving. You take and you put that color on the page, and what you put on there is what it is. And if you didn't get it right the first time, tough. With oil, you can go back and you can work it, and you can shape it, and you can make it be what you want to be. That's why I do oil, because I don't really express myself. I construct pictures. It's very much, it's just, there's software, just, if I bleed, it comes out alcohol. That's what they injected when I was an undergraduate. Okay, so in terms of the empowerment, these are actually very different. Forgiving versus cost. Okay, now the third property I want to talk about is a balanced structure. And structure seems to go against the other two, but it's really fundamental. Because if your medium imposes the right structure, it actually empowers what you can do. It confines you, it constrains you, but it actually empowers and makes possible a set of things that you couldn't do before. And this notion of structure, I actually want to change media here to talk about it, because I want to change to music. So, before I learned how to read, my mother insisted that I learn how to read music, because my mother was a piano teacher. So at age 4, I was instructed, you will learn to read music. It was the law in our house. Now, the interesting thing about music, as we look at this here, this is a small piece of orchestral score. You cannot express all musical thought with these notes. Okay? Basically, you're allowed to express the chromatic scale. If you want to make a sound outside of that, you've got to rub something in the margins or do something different, but this notation will not do it. However, this notation is an outstanding collaborative medium. Because we have specified the chromatic scale, and because we have a notation for expressing pitch and rhythm within that scale, we actually have a whole collection of instruments which can all play together to produce an orchestral sound. If you just had arbitrary frequencies as your medium, building an orchestral production would simply not work. So the structure of the notation makes it possible to make the first violin, second violin, the horns, the harps, the cellos, and the basses all produce a harmonious event, all of these people together. Without the structure, you are not empowered to do what this does. Okay, here's another one. We have the violin, and we have a guitar. Both of them have stretched strings. The guitar happens to have 6, and the violin has 4. In terms of range, the violin is superior. In terms of the emotional things that you can express in the notes of a violin, you can make it sing, you can make it cry, you can make it laugh in ways that a guitar cannot do. But a guitar has more structure. It's the frets. Because of the frets on the fingerboard, it is very easy for almost anybody to press their finger on the string and get exactly the right note. And if you've tuned your guitar correctly and you press the right fret spaces, the correct chord comes out and it works. Now, the range is limited, but the set of people who can enjoyably play the guitar is far larger than the set of people who enjoyably play a violin. Having had children practice the violin in my house, enjoyable is a key criteria. because not only can it laugh and cry and sing, it can shriek in a most penetrating manner. Okay, it's the structure that empowered many, many people to create music that they otherwise would not have been able to do. Okay, here's the piano. It actually has even more structure. With the guitar, you can actually bend the note. You can do things to sort of shape the tone. With the piano, that key has a volume control, and that's it. It's going to express exactly that note every single time. But by imposing that structure, what we now have is the opportunity to use all of my fingers and create chords and a volume and a depth of music that I cannot create with that one-note violin. To create that same thing out of that violin, I have to have a whole bunch of buddies all playing their violins. But out of my piano, it's the structure that allows me personally to express things far beyond what I can do with a single violin. Now, another thing I want to come back to is I talked about music providing this collaborative structure, and this music does. But here's another representation. Okay, this is a lead sheet out of a fake book. What it has is it has the melody, it has the name of a chord, and it has the lyrics, and that's it. Now, what you do with this is you get a bunch of your friends, some with a guitar, some with a bass, some with a fiddle, maybe a violin, who knows? You get them all together, and you can create a spontaneous piece of music that works. Why does it work? It works because of the chords. By saying that when I get to the word I, we're going to all do something in the F major chord, everybody in the room now knows where they need to fit. And if they fit in a good and interesting way, it will work. It's a structure that provides collaboration in a very different way than the orchestral score does. Now, it doesn't scale up very high, and a lot of times it helps if everybody's looking with each other, but you can have a great time with this kind of music because that structure allows you to collaborate in interesting ways. Please go to the next slide. Oh, lovely. So in case you're wondering what happened here, Microsoft decided to give me a server not found error in the middle of my talk. We will forgive them later. Oh, back up. Okay, this is another medium I want to talk to you about. This medium is actually a piece of software called Finale. And the reason I like this medium is I absolutely despise to practice. Despite all the efforts of my mother, getting me up at 6 o'clock in the morning from the time I was 4 until the time I was 14, and making me practice every single day, I really despise practice. I like music. I despise doing the same thing over and over again. It makes me a terrible bowler also, by the way. What Finale lets me do is Finale lets me create music without the practice. I can take the notation, I can create and have done create choral music to be sung by a choir. It sounds good. I can play it back on my computer. I know how it sounds before I give it to the choir to sing. And I can do things. It has empowered me to express music in a way that those instruments did not, because it doesn't require me to practice. Now, there are limits to what I can do. There are many, many musical things that I cannot do with this tool. And actually, I cannot lead the choir without Tammy, who plays the piano very well because she practiced and practiced and practiced. So you could say this allows me to exploit Tammy. But she likes it, so it's okay. All right, so let's go and think about these principles: range, empowerment, structure. And let's look at what we're going to do to create a new medium, because that's what I believe we do in the interactive systems world. So in the upper left-hand corner here is a picture. This actually isn't where I started my career in computing. I started my career in computing with punch cards. But that's the bad old days, and we're just not even going to think about how ugly that was. And yes, I do know how to paste the little Chad back in the hole to edit your program if necessary. But we're just not going to talk about that. That's the bad old days. Okay, when I started my research career, computing looked a lot like this picture in the upper left-hand corner, which is vector graphics, not raster, and every kind of input device you could imagine. Sliders, scroll bars were actual physical scroll bars, twisty knobs, buttons, keyboards, pens. And the goal was, when we first got into this interactive systems world, is you had to empower all of those things. Because what you wanted to do is you wanted to be able to create software that would allow people to express a user interface using any or all combinations as it was suitable. That was our goal. And we would write papers about mine will have that range. And then we had the Xerox Star with the immediate follow-on of the Macintosh. Well, what does it say? One of the first things is, thou shalt not use all possible devices. You will use a screen, a keyboard, and a mouse. And a screen and a keyboard and a mouse, and we have little particle rays mounted around the computer, so if you try to attach anything else, your hands will be cut off. Screen, keyboard, and mouse. And there are papers, some of the people in this audience, I know, wrote papers that said, decried what this was going to do to interactivity. It was just going to kill it because the limitation on the range of expression. And it didn't. By limiting the structure, we actually empowered a set of tools. So when you got a Macintosh, it already had built into it everything that would do the scroll bars and the buttons and the menus, and the basic things you needed to build a particular class of applications just were already there. And the set of programmers who could effectively use this was far larger than the set of programmers who were empowered with what we see in the upper left-hand corner. And we had many, many, many more applications than we ever had before. And it falls out of the structure. Did we give something up? Yes. Did what we gain much, much larger? Yes. Okay, so I'm going to use this graph here as I work my way through. Across the top is a set of applications. Do not think of this as linear or a progression in any way. It's just a bunch of applications. And the vertical axis is a bunch of different kinds of computing platforms. Now, when I started out in this business, this is what we were doing. People would go out and they would buy graphics system X with various kinds and pieces of hardware that they would attach to it, and they would build an application. And maybe on that same platform they'd build several applications, but there was always a herd of salesmen coming in your door that wanted to sell you the next cool piece of hardware, which you would immediately buy because the inner geek needed to be fed. And then you would build different applications, and they were all sort of this point kind of thing. And then big companies would spend a lot of money to replicate their application on every one of these platforms. And a lot of effort to do that. In the midst of this, there is the Star, and commercially there is the Macintosh. And the Macintosh says, there is a range in here of an interesting hardware configuration and an interesting set of applications, which was actually not the set of applications that most of us were even looking at. So that's why I drew it off to the right there, is they actually pushed us into a whole new set of things that most of us were not paying attention to. Most of us in the field at the time believed we existed to serve engineers, with a few physicists thrown in for politeness. Okay, when they did this, they actually created a medium. They gave you hardware, they gave you software, they gave you a style guide, they gave you a space to create in. And that space filled up far faster with applications than all of the other stuff that we'd done, because the medium was expressive. It allowed us to do a lot of things. Now, yes, more papers continue to be read, and trees died for the fact that this is a limited space. But it was a really exciting, interesting space. And because of the quality of the medium, many, many more applications were being built than had been built before. Okay. There was a little company once who had a software vision. The Macintosh said that the key to our space is screen, keyboard, mouse, processor, graphics processing unit, physical configuration, and the case that you could carry it with. Yes, there is the backpack that you can carry your Mac in. And they said, these are the things, this is the structure that is required to be expressive in this space. And Microsoft said, no. Screen, keyboard, mouse is the structure. Everything else can be free. And we had this enormous war, and everybody sued each other, and lawyers got entertained, and software people augmented their income, helping lawyers be entertained. But the thing that Windows did is it actually said, no, there is actually a bigger space here. And it's not just the space that we originally thought of, it's a larger creative space. What this also allowed people to do is it allowed people to write applications that went over a wide variety of hardware platforms, not just a single one. With a wide variety of processors, and because the range was bigger, the same set of people was empowered, but because the range was bigger, the economics allowed us to write many, 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 many more applications than even the Macintosh had allowed us to do. Okay? But the thing that made that happen was this idea of discovering the right structure and embodying it in an interactive platform so that people could build things. The creation of the medium. Okay, now, the Macintosh didn't go away, and in their space, they continued to be very, very, very good. It's one of the reasons why, if I go out across this audience, there are many, many people who say, I love my Macintosh. Because if you were in that space, it's very, very, very good. So we will continue to have this competing thing of more structure, which allows us to optimize and refine, or less structure that allows us to achieve a broader scope. And we're going to have that argument long after everybody in this room has retired and gone away. Okay, let's go to another one, the World Wide Web. The World Wide Web is very interesting. I personally wrote papers that said the interactivity of the World Wide Web is equivalent to an IBM 3270 terminal, which is not a positive thing to say, by the way. For those of you who don't know what an IBM 3270 is, that was not a nice thing. Okay. What's the structure? Well, the structure is HTTP, Hypertext Transport Protocol, and HTML. Those two things together, and that standard is the essence, that structure that says you can't do all possible networking things. You only do these things. You don't do all possible interactive things. You can only do these things. But what it allowed us to do is it allowed anybody who had a service that they wanted to share on the internet to write an application as a web server and know that there was an enormous number of people out there that could use it because they had a web browser. And they didn't have to deal with that deployment. It was already pre-done for them. What it also did on the other side in terms of empowerment is for someone who got a web browser, it says, if I just get this web browser, which I'm so excited that they're free, and I install it on my computer, I actually have access to an enormous number of services that I couldn't possibly waste time installing on my computer. So this piece of structure, which is the communication piece between them, by freezing that structure, we actually empowered both sides to do far more things than they could ever do before. Now, in those days, was the interactivity stinky? Yes. And we've added Java applets, and we've added JavaScripts, and it's getting better in many ways, worse in some other ways. We can argue about that endlessly. But this whole notion of liberating how I experience my user interface from how I produce the service just exploded in marvelous ways. Okay, this is one of my favorites. This is one of my favorites. Let's start with the structure. What is the structure? You get to interact in exactly one way. Type some words. And for variety, we let you type some other words. Now that is a confining structure. What does it empower? Well, if we talk about the range is all of human language, all of written human language. That's an enormous range. That simple structure actually empowered a lot of people to say, I understand how to search things on the web. I know what that means. It means I type words, and it works. Now, the interesting thing that I like about this, and the reason I brought it up, is because there are other search engines who, as they have expanded, have said, I will add more features. I will give you another collection of ways to hone and tune and craft and by date and by ontology. And the thing I like about this particular one is they resisted breaking the structure. What they did is they accepted the challenge that says, I will retain this very simple structure and I will improve my algorithms to improve the quality of the experience. So I will not change the person, I will change the technology. Now, will this give us everything we need, and is there something else beyond it? I'm sure there is. I'm sure there is. But I like this as an example of, if you get the structure right, as confining as it feels, it's enormously empowering. It's great paint. Okay, here's another one. This is the tablet, and as you can see, it has windows on it. What's the range of things I can do? The range of things I can do is exactly the things I could do on my desktop. What's the set of people that are empowered by this? The set of people that are already empowered by the desktop. What's the new structure? The same as it is on my desktop. In fact, we go to great lengths to make that pen look as much like a mouse to the software as we possibly can. So, how excited was everybody about this? It's a nice thing. I'll buy one, maybe. Okay. The range of an iPad. It turns out it's very, very different. But I want to start back with the structure. The structure is completely different. It's not screen, keyboard, mouse. It's screen and your finger and one button. We go back to that elegant, simple structure. It's your finger and one button. Now you can take that finger and you can drag, and maybe you can use multiple fingers, but that's the structure. What did it do? Well, it empowered a whole set of people. Now I have 8 children, and one of them is a software guy, and the rest of them are technophobes. Well, they will use the web, etc. But for Christmas, I bought them all Kindles. I bought them all Kindles because I'm tech dad. And Christmas Day, the grandkids are down playing with their stuff, and all their parents are sitting there on their Kindles. All these technophobic parents are on their Kindles, and they're having so much fun. Okay? The structure that the iPad and the follow-on Android imposed empowered a whole set of things. The applications we see here bear some resemblance to the ones we had on the desktop, but in many, many, many ways, they are so different. Okay, I want to come back to this diagram because this is the one I want to use to go thinking through what we do from here. What's the role of interactive systems research? Because that's what I said I wanted to talk about. Okay, let's go here. We had the violin, which could produce all this emotional content. We had the keyboard that had all this structure in our piano. But let's look at this next transition. The synthesizer. Okay, it's got a keyboard. It's not quite as wide as the one that comes on the piano. And then it can express more kinds of musical sound than your piano could possibly express. Except there's 12 people on the planet who have any clue how to do it. Because people look at all that push panel which says, I'm taking this kind of a signal and plugging it into that kind of signal and mixing it with the other kind of signal, and I've got the keyboard thing, and if I plug it all together right, it'll make this really cool sound from Star Trek. And everybody just went, really? Really? Okay, this is the same technology, but this is the way it appears in almost every band in the world. Okay? It's got the keyboard. It's actually taken. Now, what happened here is people spent time with this patch panel-y thing that nobody could understand, and they figured out what is it we can do to harness this new sound-making capability in a way that I can actually create music. Now, this lower set of keyboards can't do all the things that that original thing do. There's been structure reimposed. But I wanted to talk about this process of we launched into the void of how many ways could we mix sound and attach it to a keyboard. And then after we learned a lot about that and did a lot of really weird, dumb stuff with it, we came back and reimposed some structure and created a new set of instruments. It's just amazing. It's just fun. So, back to my chart. Computing platforms, applications, this rounded rectangle you see here, that's the world as we know it, whatever world you think it is you know. That's the world as we know it. So how do we expand on that world? Well, one approach is I keep the computing platform rigid, and I build more and different kinds of applications. And that's a good thing. That's a good thing. That's not what people like me do. Now, the frustrating thing about this diagram is this is what people who read many Chi papers think we do. And they get upset when we don't do that. Because in my mind, that's what development people do. That's what the people who work for Microsoft and Google and all those little software companies out through the world, that's what they do. They take those platforms as they've been given to them, and they extend it into all the kinds of things that you can do with it. And that's a cool and it's a good thing. Okay, the other thing you can do is this. You can say, I'm going to take this same set of applications, this known set of things that we can do, and I'm going to extend it to different kinds of platforms and devices. Okay, this one also drives me crazy. Because what it means is if you go to UIST, you'll see all kinds of different devices and things, et cetera, et cetera. And somebody always asks, can I map that cool thing you just built as a mouse input? Because if I can map it as a mouse input, I can make it do all the same things it always did. Now, the poor people at Merle who invented the Diamond Touch, as I watched their papers come through the review process, I don't know how many people said, but will it do Microsoft Word? And I'm just going, I don't care. It's a really cool thing. Please stop harassing these people. They have invented a really cool thing. So there's this tendency to say, let's make this cool new thing do the same things we always did, which actually is not very interesting. This is what I think we do. So it begins like that patch panel synthesizer. It begins with this idea that says we start going out and we reach out into new platforms and we reach in and out into new applications. Sometimes we overlap in the application space. Sometimes we overlap in the hardware platform space. But we're actually pushing down to the lower right here. How do we reach out and see new things? And the first time we do it, it's going to be a point solution. You're going to try to build one of these, and then you're going to try to build one of these. If you don't do it, you have no clue what the structure is out there. You have no clue how all this is going to fit together. You just have to walk out into the void and build something, which is really fun, by the way. It's really, really fun. Okay, and then you build more of them, and that's good. And we publish papers, and we talk to each other. Hopefully we've beaten the review committees over the head and saying, we know it doesn't look like what you're familiar with, but we still get to go march out into the frontier, because that's what research does. And then somebody comes along and says, you know, if I take this space that I sort of think is kind of like this, and I wrap it together, I think it has some cohesion. And everybody says, yeah, that's a pretty crufty looking thing there. But I think it's got some, and somebody else says, well, you know, but you miss these guys, and I wrap these guys, and I've got a little cohesion here. And then somebody else comes along and says, well, no, remember these, because if you take these, you put them together, I think there's a little bit here. And we keep groping for what brings us together. And yes, we're still staggering around in the dark, and it's kind of fun. No, it's a lot of fun. And eventually somebody comes along and says, I got it. I got it. The structure looks like this. The structure looks like this. Now, the interesting thing is when this happens, it usually happens that a company does this. They put it all together, and the structure looks like this. And the rest of all that stuff that happened never existed. It's all gone. We invented this completely out of the intelligence of our insight, and it really didn't have anything to do with all that stuff you did populating that, pioneering that space. And we all get cranky and grumpy, and we go off and do what we do anyway because it's just so much fun. And that's why we did it in the first place. Okay, it is this process of building the patch panel synthesizer just to see what we can do, and then discovering eventually the structure that creates a great medium that lets people express themselves. So let me give you a couple of examples of things that we've done in our lab. So one of the first ones that we've done recently is interactive television. Somebody came to us and said, we've got this great technology for transmitting video over the network. We'll give you a bunch of money if you'll do something interesting with it. And being the kind of person that I am that loves to break stuff, the first thing I did is he started playing this over the internet and says, well, cool, and what happens if I grab the slider bar and go like this? Which usually mean loading, loading, loading. And in this particular technology, it went pop. Whoa, that's cool. Let me do it again. Yeah, ooh, that's cool. And so what we did is we said, oh, okay, here's a new platform. How do we create a medium out of this? How do we create a mechanism for people to build new television? So here's the first one we did. We said, okay, when you do a sports game, one of the reasons we did this is everybody in the lab at the time all liked BYU football. So this allowed us to go hang out in the BYU football truck and have a great time. So you take all 6 cameras that are down there in the field, and you actually digitize all of them, and you put them up on the internet. And it's great. And then what you do is you go to people's homes and you give them a little box and you say, okay, we'll give you this box. We're going to give you this panel down at the bottom. If you pull this little button right here, at all times it will show you the things you can do to play. And what you can do is you can actually rewind and fast. You don't fast forward, you skip to the next play, because fast forward is stupid. What you really want to do is go to the next play. Or you say, I want to play that play over again, or I want to play it over from a different camera angle, and everybody's having a great time doing their own instant replay from their own angles. Now, I put up volleyball. Basketball is a big hit here, because every basketball fan on the planet wants to be the ref. So somebody goes up for a basket, and every living room is going, did they really? No, he touched it. No, he didn't. No, he didn't. Look over, and they're just arguing about it endlessly, and it's great fun, and it's a really enjoyable thing to do. Now, what this did is it created a structure. It says, if you want to interact with your television, with your sports, you can only do a very few things. But on the other hand, if you want to do a sports production, it's very easy. It's very easy to create a new interactive sports experience. And it's very easy to learn how to use it. Okay. This one is one we call flexible storylines, and we're not actually as happy with this one yet. Because what we were looking for here is says, I've got a documentary story, and I'm going along, what kinds of interaction would I like to do? Well, I think I would like, when I see something of interest to me, I would like to learn more about it. Well, what have I got to do to make that all flow together interactively? And I won't bother to explain this diagram to you right here. It's basically, instead of having the cuts that you normally have in a video layout, what we've given you is several different kinds of things. And it actually takes us about 15 minutes to explain this to people who build documentaries. If you shoot a clip like this and put it there, and shoot another clip with this clip and put it there, the interactivity will all work. Now, the reason I'm not real happy about it is we just haven't built enough stories to deploy it to see how it works. In fact, one of the things we found was that it's easy to explain to video people how to do this. They had a much harder time figuring out, okay, I can do it. Now, what do I create with it? And we're still working with that because it's sort of like we gave them a power that they weren't sure what it was good for. Because these are people who have been trained for a very long time how to put together a linear and how to control the attention and the pace and what it is people are thinking as they work their way through their linear story. Okay, here's another one we did. In fact, we've just completed a deployment in a large number of homes. What we did is we took the news and said, okay, how do I want to make the news interactive? Well, the first thing you can do, of course, is once you've digitized the news, the order in which the stories appear is irrelevant, and you don't actually have to watch all of the stories. And when you tell the news people they don't have to actually watch all of your stories, the accountants just cringe in horror because that means you're not going to watch advertising, which means the revenue is going to drop and the world as we know it will collapse. So what we did is says, okay, let's replace that with other things that might be of interest. And so what we did is we searched around and says, what else could we do? Well, the first prototype we did of this is we said, when you go out and do a news interview, when you actually go up on Capitol Hill and interview the president of the legislature and ask him about the budget, he actually gives you 10 minutes. And then what you put on television is 90 seconds, or maybe 30. Okay? Now, for people who actually care about the budget, our hypothesis was, oh, those people would like to skip over whatever Britney Spears did this week and actually see what's going on with the budget in the legislature. So we just take the cutting room floor material and put it in. We're not sure how well that works because one of the things we found is if you just put a little sign up on the screen that says there's new material to watch, nobody cares. In fact, they're not even sure what it's there for. So the second prototype we did was we used a bunch of historical stuff. What we did is we said, okay, what I'm going to do is I'm going to give you the CNN version of this news story, and then I'm going to give you the option of going over and watching the Fox version. Because everybody that lives in the United States knows that those are not the same story, despite the same original facts. So I'm going to let you look at both sides, and I'm going to let you pick up on the history of what happened. But what I'm going to do is I'm actually going to insert things in that's going to pitch the story. Like you see on the news now that says, if you want to know more about this story, go to blah, blah, blah station.com, and you can see the rest of our stuff. They're constantly telling you, says, we'll do that with the extra material. It turns out that worked. Even though you still got that sign up there, people ignored it. If you actually personally invite them to go look, they do. And the news people are really delighted about that because maybe they'll watch the news more and I'll make more money, which is the goal, of course. News is secondary. Okay, and the other one we're working on right now, which we're just getting started in, is this. The world is running around carrying these in their pocket, but we're actually physical beings that actually live in a much larger scale than this. So how do we make the desire to work in the size of my arms and legs and body work from this, which I love to carry? And so, to feed the inner geek, I went out and bought as many big screens as I could afford, and then went out and bought some more and covered all the walls. Because the other thing is you cover all the walls of your lab with screens and make things flash on them, and the students walk by and say, I could work here, or I could do operating systems. Advertising works. I get all the best ones because this is lots more fun than operating systems. Okay, and I would tell you more about what we're doing, but we don't actually know what we're doing yet because we're in that stage of populate little points of things that we can sort of try to kind of figure out what's really going to go on here, and I can't give you a coherent structure. Okay, so let's wind this up a little bit. The first thing is, in what I do, we are constantly pushing to the lower right. How do I go out and find new hardware, new computing platforms, new software platforms, and build things that people could never do before. And I start out by reaching out there with little points that are kind of dysfunctional, but they're just trying to help us understand what's out there. The next thing we do, which is the part that's probably the least understood, is take those points and see if we can find some coherence. Where's the structure? How can we put these together in a way that will make sense software-wise and will make sense to people who actually have to use that? And we sort of stab at it and struggle at it. And this is one of the things that makes this particular step hard is the fact that it's a little big and it's slow. And when you write the paper about how it works, people who have never experienced the space don't know what you're talking about because they never lived there. There's nobody that lives out there. So trying to explain to them what it's like is actually hard and frustrating. Okay, but what we're after is, can I build the next paint? Not paint the next painting, build the next paint. The next medium, the next way for people to express themselves. For me and others who do what we like, it's in this area of interactive technology. We want to build we want to be the Da Vinci of interaction. And the key is to focus on a medium. I'm going to create a medium. I'm going to create a technology for expression that has a wide range of things I can do. It empowers people in a way they were never empowered before. And it encapsulates a structure, a way of understanding, simplifying, conceptually compressing what it is I'm trying to do. And if I get that all together, I win. So, in closing, inside here is a little tiny kid who just loves playing in this pond. And for the last 4 decades, it has been so much fun to play in this pond. It's just the coolest thing ever. But since you only get this stage every once in a while, one of the things that I really wanted to share with you is how much fun it's been sharing that pond with all of you. This group of people is a wonderful group of people. Yeah, sometimes we're a little quirky and sometimes we get crosswise with each other, and we always whine about the paper review process. It's a right. But it's been so much fun to spend it with you, and I appreciate it, and I thank you. What you got for me, Don?
Okay, I'm Don Norman, and what's kind of interesting is, gee, we have Greg and we have Austin. Good set of people. That's a brilliant talk.
Thank you.
I really liked it. And I work a lot now in product design, which is all sorts of things, not just software. What I was doing was translating what you were saying into how we're thinking about moving into new product designs. And your talk translates precisely. It's wonderful. But there's one really new important concept in there that you emphasize that I think could really be powerful in product design, which is it's not a new technology, it's not a new thing, it's a medium. And the change to a medium is what's really critical. And that's what you're really saying, and that's wonderful. And there's one other amusing difference, is that you showed progress on the vertical axis is going down as we get new things. And usually it's up, and so most of us don't aim for the lower right-hand quadrant, we aim for the upper right-hand quadrant, which is the same one that you're talking about.
Yeah, on all raster graphic screens, though, Y is down. The techies understood. The inner geek just creeped out.
Now, there is one other step, though, that I'd love to see you take, which is one thing that bedevils those of us in product design, which is we have these great ideas, we have a great new medium, we have the great new potentials, but actually it fails in the marketplace. And one of my favorite stories is one of the first products I ever watched get launched, and it failed. It was a digital camera. Who would have ever thought of a digital camera? It was produced by Apple, so it was a pretty good job, but it was too early.
It's like the Newton.
No, the Newton had other failings.
Yes, it did.
But the Newton failed actually primarily, I think, because it was marketed badly. If we had never mentioned handwriting recognition, because our phones today don't have handwriting recognition, it would have done just brilliantly. But all I want to say, and let these people have time, is I'd love to see you go a little bit further and say, now that we have these ideas and you're doing interactive television, but you're going to find great reluctance in not only the companies, but people to actually buy this. It usually takes decades. So can you add to your story to understand that? The same thing happened in painting and in music. New styles, the audience rejects at first, and 100 years later we consider it masterpieces.
So if I could answer that, I would be enormously richer than I am now.
Oh, that's not a bad idea.
My kids would appreciate it.
Dan, thank you for a wonderful talk. 2 points I want to make. First is that you're very inspiring, at least to me, because you demonstrate that you can be intellectually challenging and entertaining. And I really appreciate that kind of model to aspire to.
Thank you.
As a little caveat, you also set the bar very low as to what it takes to be funny. So it makes it easy for some of us. The second point I want to make is there's this thesis that I've been kicking around in my mind for the past few years that I wanted you to kind of comment on. That I've been wondering about what's been delaying the UbiComp revolution from being as mainstream as the personal computing revolution. And I made this observation that in the PC world, the design time environment is a two-dimensional graphical user interface, and the runtime environment is a two-dimensional graphical user interface. But in the UbiComp world, the runtime environment is this physical environment, and we still demand that we build it, design it in a two-dimensional graphical user interface. So I wonder if you could kind of comment on what we need to do to kind of move out of that two-dimensional graphical user interface to that structure so that we might be able to help people play in the UbiComp space better.
So this requires me to confess to some intellectual ADD, which is, yeah, I thought about that for a while 4 or 5 years ago, but I never last more than 3 or 4 years on an idea because I'm constantly on something else. But one of the things I've looked at is, you know, how do you actually go express what I want to build in this physical world? And we actually spent some time going out and saying, how do I create, how do I design? So this is why we did the image processing with crayons. How do I actually get into image space and draw examples of what I want to do? And we looked at some interactive machine learning, and I think there's some more stuff there. I think the other thing we struggle with in the UbiComp era is that we're still a little bit, you know, pay no attention to that ribbon cable behind the curtain. We've still got too many patch cords hanging off of it because the technology hasn't caught. I mean, one of the things that the iPad has an advantage of is that the electrical engineers, as much as I malign them, the electrical engineers finally delivered the platform that could come into your hands and didn't have gooky, quirky things off of it so that ordinary people could accept it. And so in the UbiComp area, we're still struggling to find, can we get the technology that makes the package smooth? And of course, this is where I do my usual rant is, let's get the wireless networking people to fix the really stupid technology so that it's actually smooth instead of clunky. And I don't want to read a EULA every time I hook a new device up.
Again, Dan, thank you very much. It's great. My concern is with software and the accessibility of software, that is to say programming, to that larger range that I think we might aspire to getting. How, and maybe I'm wrong, but it seems to me the range of those who can program, those who can do the chemistry to decide that wax or, won't hold color or whatever it is, are still a very small part. We're not making the capacity of living, breathing, machines running code or some equivalent available to a broader range. Or are we? How do we,
So-
the central stuff, how do
Yeah,
we get it out there?
There's two thoughts I have in response to that. So the first one is this whole, how do I express and can I get a different, and this is actually a story of failure and loss. So in my early career, I said, having once been a compiler guy, we can express user interfaces as automata. Well, what happened is along came a bunch of people at Xerox and said, no, object-oriented programming is a better expression. They were right, I was wrong. So to some extent, we have been getting some of that.
Yeah.
I think people are starting to try to develop languages so that the disconnect between JavaScript and the website can be smoothed out. And it's a hard thing. I mean, trying to convince programmers to change languages, it's hard, having been there. The other one that Scott and I have talked about on occasion, and that is the number of students who are prepared to crack open the hood and learn how to build new things like this is actually diminishing somewhat. Students come to CHI and they get excited about the design aspect because it's just cool. And sometimes they say, I don't really want to spend all that time to master the mechanics of paint. And so one of the things that I am concerned about is, are we getting enough people who are out there trying to rebuild these substrates? And I think, the iPad and the Nintendo Wii and the Kinect and the number of ways people have broken the hardware mold recently will help, because a lot of people are saying, I don't have to confine my life to Windows.
Now you've got a lot of pieces, but you got to glue them back together again.
You got to glue them back
With this
together.
stuff which is way down at the level of chemistry.
Yeah.
Thanks.
I don't have a great answer for you there, other than I'm going to have a good time.
And Dan, so as someone who's had to kind of explore these points in that big space of yours, I know that exploring each one of these and building one of those takes time and effort. So my question is whether you see that if you can potentially arrive at the compelling structure platforms you described faster, instead of by perhaps more cleverly choosing the points to explore, or do you think there are no shortcuts to that?
If it's easy, people have already done it. So it's sort of like what I tell a lot of my students. Why do you actually dig into this hard stuff? Because the skills of the hard stuff are where the big gold is buried.
So
and if it's easy, people have already done it.
So you think that we should kind of go as far to the bottom
Reach
corner.
out there. Yeah, reach out there. Wander into the frontier. And for those of us who like to do this, we actually have to be a little protective of people who try. Program committees, funding committees. For people who are reaching really hard and sort of groping in the dark, we need to support that, because that's where the research is. That's where the excitement is.
Thanks.
Speak to us of notation.
Notation.
You made a point about the various different kinds of notation which were used in music, and the role that played in taking the structure and making it available. In our field, the notations. What are our notations? Are they getting in our way?
Yes. Yes, they always do. One of the things that always happens with technologies like this is they create a path of least resistance, which is good because that allows the prolific explosion along that path of least resistance. Breaking out of it is hard, and one of the things that happens is it's sort of the Turing completeness problem for software geeks, which is I can express this piece of the interactive problem, with a notation, and how do I make it fit with the functionality that goes behind it, which is general purpose programming, and we have failed at that connection more times than we've succeeded.
Jason Hong, Carnegie Mellon. So I want to say first, thanks for a really awesome talk.
Oh, thank you.
I have several questions. So the first one is, why do you think it's companies that are doing all this integration and rather than researchers? Should we as researchers be trying to do more of these integration of platforms? And are there reasons why we're not doing it more? Is it because of, is it a money issue? Is it incentives? Is it peer review? Something else?
Couple of things. I think part of it is the money. I mean, the other part of it is the time. What's the number of graduate student hours per publishable Chi paper, kind of thing. And if you start to get into these integration projects, the other one a little bit too, though, is the management structure required to actually field. So if you go from Jeff Hahn's, two-handed kinds of things, which are very, very elegant, which you can do with him and a few people, and you go from that to the iPad, the industrial structure required to make that happen is really beyond what university professors do well. And it's coupled with the money. It's coupled with the money. And it's also coupled a little bit, also, to chide the community a little bit, is that we are a little fixated on, does the new graduate student we intend to hire have 25 publications before we hire him? That's a bad thing we're doing to ourselves, because what we're doing is we're forcing our new researchers to say, slice it up really small or do a lot of little tiny things, because you won't have 25 publications to get that really cool job if you actually take on the bigger problem. And that's a self-inflicted wound from our community.
So I'm glad you're mentioning these things, because maybe I should ask the second question more directly, which is that what other things can we as a community of researchers be doing to facilitate this birthing process of new apps and new platforms beyond just publishing papers?
I think look for bigger leaps and expect fewer papers. Fewer, bigger papers will do us a lot of good. I think there's a lot to be said for, I'm documenting the landscape, I'm mapping out what's out there, but I think we get a little too focused on that and not, what does it mean? Because what does it mean actually is hard. It's hard. And you'll get it wrong.
Thanks, Dan.
Hi, Dan. Michel Baudouin from Paris Student Stanford. So thank you for a very inspiring talk. And a few years back we did this thing for 20 years of UIST, and I had great fun interviewing you and a few others. And your role in the community has been great, from building up the community and making people have roles. So like people like me, will be helping with Chi next year and things like this on publications and helping people to get their stuff out and sort of shaping the review processes and all the things we do. So it's been an inspiration for me. The question I have is, the saying that the sons of the shoemakers have the worst shoes. So when we build systems, the tools we have really stink. Creating websites or apps is really complicated. So how do you see the structures that we could use to make this better? And is this worth doing, or it will always be inadequate because we're always leaping for the next thing, and therefore the tools will never be the right ones?
Yeah, the question you asked is one I wrestle with myself a lot, because it's fundamental, I think, to computer scientists, which is I have a task to do, and it looks like a long task. I think I can build a tool. And then I start working on the tool, and I said, this tool is hard, and it's a long task. I think I can build a tool. And this sort of recurses back on itself. So I wrestle with this all the time, and I have to keep so I go up the stack and back down the stack, and where's the right place in the stack, I actually don't know, because I just continually wrestle with, if I keep tooling and tooling and tooling, then I never actually produce anything, but if I get down too close, then all I'm doing is trying to paint bad paintings rather than create new paint. So I don't have a great answer there, other than I get it wrong a lot.
No, let me try to push on that a little bit. Maybe Michelle could help too. That I think part of this has to do with the way academics work. That I'm a scientist and I have this great idea, and so me and my graduate students, and we program it and we have this illustrative case. And it only works though if we're standing there and tweaking it, and when we demonstrate it, we have to demonstrate it, because if someone else uses it, they go into the dangerous spot.
It blows up, yeah.
Okay, but we're successful, we're happy, and we publish it. And now we go off and do something else. Because we're happy once we've demonstrated the concept works. And what we need to make really great stuff is a lot of people come in and build on that structure. But you don't get promoted if what you've done is just some little iteration of somebody else's structure. Companies hire you to do that, but not in academics. And that's why your notion of we should do the big, important papers fails. It's the correct idea, but you don't get past the promotion committees. So if academics could somehow, the physicists do it, get together and say, we're all going to work together on this platform to enhance it and build it, and the people in Paris are going to work with the people in Utah and work together to make this more powerful so we can all really create something that's lasting. I think the problem is this fact that you do something that's neat and you do it in Chi, and now you're finished. Now you have to do the next thing.
So I think there's another problem there, which is actually a little bit fundamental to why we have the jobs we have. And that I can't speak for all of you out there, but I am very heavily a shiny bubble personality. And so what happens to me, frankly, is when I get to that point and I've got that insight, and we're there with interactive television right now. You know, we've done a bunch of really good things and people like it. And I said, we could build a company out of it and all this stuff. And I'm going, I want to do wireless displays. And I think it's fundamental in the personality that can create. At least for me, has a really hard time with becoming the personality that manages.
Actually, I've talked about what I call the research practice gap, and I claim we need an in-between person. When we were at Apple, my research group would do wonderful stuff, and I'd bring it to the product groups, and they'd say, "That's really neat. Give it to us. We'll put it as a product." And I'd say, "It's written in Lisp, and it only works if the person is sitting there." And they say, "Well, make it into good code." And I would say, my brilliant scientists are incompetent at making solid code. That's not what a scientist does.
Yeah.
But here's another point. Isn't it that it's by also building the tools that we understand the structures that we are dealing with?
Yes. A lot of that comes there. I mean, a lot of it, I mean, when I think about this whole object-oriented programming for event handling versus the automata approach that I took, I mean, having taken both of them and finally coming to this understanding, having built both of these kinds of tools and saying, interactively, the things you're working with are more important than the sequence of events. But if we hadn't have tried to do all that, we wouldn't really understand that insight that's driving the way we build so much software today. So I think you're right, yes. Trying to make a notation, trying to encapsulate, it's this search for structure. That's what we do. And we get it wrong, and then one day it sort of goes chunk, and somebody else makes an enormous amount of money. I think we're getting close, so go ahead here, and I'm going to let all the rest of you run away and get your donut.
Lauren Trevine, University of Minnesota. Thanks, Dan, for a great talk. You talk about trying things and failing, which obviously is a good way to learn. What are your thoughts on how to fail intelligently? I know when I failed, sometimes I feel like I learned nothing from that. It was a dumb thing to try. Nobody else is going to learn. How do you fail intelligently?
I'm sorry, the thing that comes to my mind is Toy Story, and that's not flying, that's falling with style. And the answer is I don't know. The key is fail privately, and then they think you were intelligent.
You know, we sometimes say that when you do a project, a study, that you want to design it so that however it comes out, you learn something. Is that something you think is actionable, or is that just a nice idea?
I'd like to think I do that, but to be intellectually honest, it's no matter how this comes out, am I really going to enjoy the ride? That's just who I am. Thank you.